Alright, tonight what we are going to be talking about is how to convert between moles and various units that you use in chemistry. What they realize is that a mole, or the 6.02 times 10 to the 23rd particles, actually translates to very specific amounts. For example, every 1 mole of an element, there are a certain amount of grams for that element, and that is called its molar mass. Okay? This will change depending on what substance you are talking about. So in order to do a problem, what you need to understand is we're going to do proportions again. When I am asking you to go, for example, between moles and grams, I am going to set up a relationship between my unknowns and my knowns of my molar mass. So, very first thing you ever need to do if you are given a grams problem is find out the molar mass of the substance that you are talking about. For this example, we have 1 magnesium, and each magnesium has 24.3 grams. I add that to the 2 chlorines, which each has a mass of 35.5 grams. So total, I know that if I had 1 mole of magnesium chloride, I would have a mass of 95.3 grams of magnesium chloride. So I am going to set up a ratio. I know that for every 1 mole of MgCl2, and yes, you do need to write out the magnesium chloride, for every 95.3 grams of magnesium chloride. Okay, I know that is a true fact. That is my ratio. Now I'm going to set it up to my proportion of how many moles are then in 28 grams of this substance. Well, since I'm trying to find out what moles is, I'm going to put that on top. Okay, the reason why I put my moles on top is because moles was on top on the other side. If it was not on top and moles was on the bottom, I would put X moles on the bottom for this ratio. So it's going to be X moles of magnesium chloride over 28 grams. Okay, and then I'm going to cross multiply in a solve, and I get X equals 0.294 moles of magnesium chloride, MgCl2. All right, another one that we're going to have to do is go from moles to grams, and it works the exact same way using the molar mass. So once again, you're going to have to calculate the molar mass. So I know that nickel, I have 3 of them, and each nickel, according to the periodic table, has a mass of 58.7 grams. I have 2 phosphoruses, each one has a mass of 31.0 grams, and I have a total of 8 oxygens, each with a mass of 16.0 grams. Total that up, I know that if I had 1 mole of nickel 2-phosphate, I would have a mass of 366.1 grams. All right, so now I'm going to set up my proportion. I know this is fact. I know that for every 1 mole of nickel 3 or nickel 2-phosphate, or Ni3PO42, I have a mass of 366.1 grams. Oops. Sorry, we're going to have to get that on. Okay. 366.1 grams of the nickel 3-phosphate. Okay, so I'm going to set up my proportion. What I want to solve for in this case is how many grams. So I'm going to find where grams is, and I'm going to put X on the bottom because grams is on the bottom. So I'm going to write X grams of nickel 3-phosphate, or nickel 2-phosphate. But I do know that I have a total of 1.3 moles of this. So, once again, I'm just setting a proportion, and then you'd write nickel 3-phosphate again, or nickel 2-phosphate again, and then you're going to cross multiply, and for this one, you end up getting 475.93 grams. Okay, but rounding to sig figs, there's only 2 sig figs in this number, so 1, 2, that is going to round to 480 grams of nickel 2-phosphate. Alright, so once again, we're going to be using proportions throughout this whole mole conversions unit. Okay, all you have to do is figure out the ratio with 1 mole. Alright, what they also discovered, scientists, is that if you had a mole of a substance in the gaseous form, it's STP. And what does STP stand for? Standard temperature, and pressure. Standard temperature is defined as 273 Kelvin or 0 degrees Celsius, and standard pressure is 1 atmosphere. Okay, you should remember that from our previous gas unit. But what they figured out that is all gases, no matter what substance you're talking about, all gases, if they are at this specific temperature and pressure, they take up 22.4 liters of it. So if I had 1 mole of it, or 6.02 times 10 to the 23rd particles of it, at standard temperature and pressure, it would take up 22.4 liters of space. So for this one, calculate the number of liters. So I know I'm solving for X amount of liters of 5.5 moles of oxygen. So I'm going to set up 5.5 moles of oxygen over X liters. And I know from the previous conversions to the left of these notes, I know that for every 1 mole of oxygen, I have 22.4 liters. So rounding and multiplying, what you get is 123.2 liters of oxygen when you cross multiply, and then rounded to the 2 sig figs from that 5.5, you get 120 liters of oxygen. So once again, we are just setting up proportions. When you set up proportions, make sure that your units align. So if moles is on top, it's got to be on top on the bottom. If liters is on top on one side, it's got to be on the bottom for the other. All right, as we've stated time and time again, we know that 1 mole is defined as 6.02 times 10 to the 23rd particles. So now in order to do a conversion with that, what we want to do is if we're trying to find out how many moles of sodium sulfate I have, and sodium has an Na with a +1, sulfate is SO4 with a -2, so when you cross multiply you get Na2SO4. Okay, I'm solving for moles, so I'm going to put it over my 4.5 times 10 to the 22nd molecules, and I'm going to abbreviate molecules as MC. Once again, make sure you put what substance you're talking about, so Na2SO4. I need to set up my proportion, so I know moles of the Na2 has to be on top, so I'm going to write Na2SO4 on top. And I know, sorry, it should say 4, my pen's a little goofy. And then I know I need to put molecules on the bottom, so I'm going to write molecules of Na2SO4. So I'm going to look at all my numbers, and I know that for every 1 mole, I have 6.02 times 10 to the 23rd molecules of Na2SO4. So when I cross multiply this, I get X equals 0.075 moles of sodium sulfate, which is Na2SO4. Rounded to the 2 sig figs from the 4.5, I am right with the 0.075 moles. All right, what's amazing though is that if you know that 1 mole equals 6.02 times 10 to the 23rd particles, and 1 mole equals a certain amount of molar mass or grams, and 1 mole equals 22.4, what I can do is that I know that if 1 mole is equal to all of these ratios, which means that the certain amount or the molar mass of a substance is also going to be equal to or proportionate to the 22.4 liters of that same substance at a gas at STP. Or if I have 22.4 liters of a gas at STP, then I know that I have 6.02 times 10 to the 23rd particles. So what we're going to be doing is we're going to be doing a lot of different ratios with this. So how many atoms? So I know I need to solve for atoms, so I'm going to write down X atoms. Okay, X atoms of Li2S, or lithium sulfide, are in 45.6 grams. So I'm going to put over 45.6 grams of Li2S. Now, according to my conversions, I can just directly convert. So I'm going to do 6.02 times 10 to the 23rd atoms, because that's what it says on my ratio chart of atoms of Li2S, is proportionate to the molar mass of lithium sulfide. So in order to do this, I need to figure out my molar mass of lithium sulfide. So it's 2 times lithium's molar mass is 6.9, and I have 1 sulfur, which has a mass of 32.1, and I'm going to multiply that out, and I get 45.9 grams. So I know that the molar mass of lithium sulfide is 45.9 grams. So now all I have to do is I have to cross multiply, and when I cross multiply, what I'm going to get is 5.98 rounded to the 3 sig figs times 10 to the 23rd atoms of lithium 2 CO2 sulfide. And actually this should say, instead of atoms, it should say molecules. So we're going to cross that off and write molecules. Okay, so cross that off and write MC for molecules. All right, another one that we're going to do now is it asks us to convert from liters into grams. So I'm going to write X grams of CO2 on top over 34 liters of CO2. I am going to assume that it is STP even though it does not directly state it. All right, so now I know that my conversion would be 22.4 liters of CO2, and I need to figure out the molar mass of CO2. So I know that one carbon has a mass of 12.0 grams, and that I have two oxygens, each with a mass of 16.0 grams. And so multiply that out, I get 44 grams. So I know that if I have 44 grams of CO2, I would take up at STP 22.4 liters. All right, once again, all I'm going to have to do is cross multiply to figure out how much then 34 liters of CO2 would have as far as a mass. And I get X equals 66.8 grams. But rounding to the two sig figs that are found in 34, I would round 1, 2, so that would round up because that other number is in 8. So it would be 67 grams. All right, hopefully you have a basic understanding of how we do conversions in this class between grams, particles, and liters. Have a good night.